In this video, I'll talk about how I want you to think about and learn amino acids. Amino acids have the structure NCC. A chain of amino acids in a protein is NCC, 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 and so on. So that's the backbone, a nitrogen, a carbon, and a carbon. The amino end has two hydrogens. That's an amino group, and it's where we get the name of amino from amino acid. The other end has a double bond oxygen OH. That's a carboxyl group. The middle carbon is the one where the amino acids differ. We usually draw that with an R. R just means any other atoms attached. Before we talk about the different amino acids, the different R's, I want to talk about the characteristics of amino acids from these amino groups and carboxyl groups. The acid part of amino acid comes because this H can leave as an H+, leaving behind an O-. So when that hydrogen is gone, H+ is gone, that contributes to acidity. We wind up with a negative charge behind. But this amino acid as a whole doesn't tend to make things more acid because this nitrogen can attract an H+. So losing a hydrogen here but gaining one here, amino acids have characteristics both as an acid, the carboxyl group, and as a base, the amino group. Going back to NCC, when these are combined into a protein, we lose one of the hydrogens and we lose an OH from the carbon at the other end. Those are joined when peptide bonds are made as water. This is the peptide bond. And left on this carbon is a double bond oxygen. On this nitrogen, hydrogen here, and here on the next one we'd have a double bond oxygen. We'd have an R group, one hydrogen, R group, double bond oxygen, N. So when you're thinking about and learning amino acids, first think NCC. That is the foundational piece. That's the backbone of a peptide. Then amino, on that N, add two hydrogens. And acid is this carboxyl group, OH, that can lose a hydrogen. And the amino group is basic. It can pick up this hydrogen. Then, once you've got the NCC, the amino group, the acid group, then add the R group onto this middle carbon. That can be as simple as another hydrogen. So it could be NCC, hydrogen, 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 double bond oxygen, OH, or more complex structures. But amino acids never get more than a few additional carbons and side groups on those. In another video, I'll talk about the different R groups.